where we were on, what, Tuesday, I guess it was?
Yeah.
Is we were looking at this guy. And I said, hey, we're out of time. Why don't you guys try it? So, let's see what we can get here. All right. So we've got this graph, which is very large. Do that. There we go. Nope, too small. Okay. So you're given this graph that shows position versus time. Clearly, simple harmonic motion, right? Because it's a sine or a cosine graph. Okay. So here's what the problem tells us. It tells us that the mass okay, so it tells us that the mass is 0.020 kilograms. It tells us flat out that it's in simple harmonic motion. It says the horizontal axis on the scale is set by TS equals 40 milliseconds. So that means the time to get to this point here is 0.04 seconds. Cool? And then A wants to know the maximum kinetic energy of the block. So, I guess it would probably do, since you guys probably haven't thought about this too much, let's take a quick second and review the equations that we sort of have at our disposal. All right, so in fact, let me just make a list. All right, so here's the deal. Here are the equations that we learned the other day. So the position at a given time is going to be equal to your maximum position times the cosine of, remember, what did omega stand for, you guys?
Not angular velocity.
Not angular velocity, but angular frequency, okay? All right, times time plus some phi, right? All right, by taking the derivative of this, we can get the equation for the velocity at time t. Gives you negative omega times x max times the sine of omega t plus p, or phi, or pho, or fum. I'm going to stop that joke now. Taking one more derivative gives us the acceleration. Cool. So that's a super quick review of the sort of simple harmonic motion equations we looked at. So we also learned that the angular frequency could be expressed as 2 pi over the period, right? Because you're going to complete 2 pi radians worth of cycle every period, right? By multiplying this equation by mass, you guys remember what happened then? So if you multiply this by mass, you get that your net force is equal to, here, I'll just do it. So if you multiply both sides of this equation by mass, you get that the force at time t is equal to negative m omega squared x max cosine of omega t plus phi. So what was the thing that we were excited about here, you guys?
It's position. Yeah.
Yeah, this dude here is position, right? So this just becomes... sorry, I changed all the colors of my pens for a reason that you guys don't care about. Force of time t equals negative m omega squared times x at time t, right? So do you guys remember what the next step was? What did we do? What's the definition of simple harmonic motion, you guys? This is big. This is a thing you guys need to know. Anybody remember? You have your notes sitting in front of you. What's the definition of simple harmonic motion? Force in which the motion is proportional to the displacement, right? So look, I just came up with an equation for force. Here's displacement. What's true about this? It's a constant, right? So we said, all right, let's call that constant K. Cool? All right, and then combining this equation equation, oh, that was a bad choice of colors, wasn't it? Combining this equation with this equation gave us this. Period, that color's terrible. Period is 2 pi root m over k. Does that ring a bell? All right, so that's a like 5-second crash course in everything we did on whatever day that was, Tuesday. All right, minus the energy stuff, right? So, but energy is exactly what it's always been, right? Kinetic energy is 1/2 mv squared. EPE is 1/2 kx squared. Cool? All right, so somehow we need to take this garbage here, this graph, and find out what the maximum energy is. All right, so I see a couple ways of doing it. Thoughts? Sure, get us started, Christine. Find the maximum velocity. Okay, so talk to me about how I can find that maximum velocity. Okay, yeah, so look, our position at time t is x max times this, right? So that means that our maximum velocity is whatever this max is, right? Follow? So I know my x max, I know I can find omega, right? So I can find my v max. I think that makes sense. Do you guys understand why this is v max? Right? Because what's the range that sine can take on? -1 and 1, right? So when sine is 1, that's the biggest possible value that can have, times this, right? So Vmax is just omega times x max, negative, right? Clear? Okay, cool, love it. So, but in order to do that, we got to find omega. So somebody help me with finding omega. Maybe we should do this. Let's analyze the graph a little bit more. The graph gives us more information, right? For example, by looking at the graph, I can figure out that my x max is what? 7 centimeters, right? The graph tells me some other information. How long the period is, right? The period is the time for one complete cycle, which happens to be the same as that TS, right? 0.04 seconds, right? Follow? All right. And based on what Christine just told us, she told us that Vmax should equal negative omega times x max. So what do I need to find? Yeah, let's find our omega. So how do we find omega, you guys? Pi over t, right? So let's see, omega is 2 pi over t. So that's 2 pi over 0.04. That's going to give you what? Is it 15.7?
157.
157? What are the units on omega?
Radians per second.
Radians per second, right? All right, everybody good there? Okay. All right. So we've got our omega. So now we can find our Vmax. It's negative omega, so negative 157 radians per second, times our x max, which is, and we should probably use meters, huh?
Yeah.
So 0.07 meters. And that gives you a number. I don't think I solved this way, so let's look at Vmax right now. Did I ever write it down? No, I solved it a different way, so I didn't find it. Also, I had different numbers when I did this.
11.
So what does it give you, 11?
Yep.
Really? Okay.
10.99.
11 meters per second. Okay, cool. Good? Do I need to worry about the negative? What's the velocity? So that's actually the minimum, right? Would be negative, and the positive would be cool, because it oscillates between a positive and a negative velocity. Cool? Oh, and you're going to square it out anyway, right? Okay, so now to find our maximum kinetic energy is 1/2 mv squared, right? So that's 1/2. The mass was 0.02 kilograms. The velocity we just got, it's 11 meters a second. Don't forget to square it. And so you're going to get, what, 1.21 joules?
Yep. Oh, yeah. It's 2 times. Yeah.
Good, you guys? Any problems? All right. Now, when I did this, I did it slightly differently. All right? So you've got this thing that's oscillating, right? So at this point here, do you guys agree that at the point where it stops, your elastic potential energy is at a maximum? Right? And when it gets to its equilibrium point, your elastic potential energy is 0, right? For all intents, right? So doesn't that mean that my elastic potential energy max should equal my KE max? Right? So when I did this, what I did was I said, well, let's just find the maximum elastic potential energy. Right? Because elastic potential energy is just 1/2 kx squared. Okay? So x max is easy to find. Right? We found omega. How do I find k? This is the big piece that people struggle with this in this section. What is k? Negative mw squared, right? Or m omega squared, right?
Is it negative or is it
No,
positive?
it's positive.
Oh, you're right, it is positive. My bad, because it's negative kx squared. You're right, you're right. All right, follow? So that, if you do that, it gives you the same answer. Yes?
So I just got Vmax equals Xmax. Just looking at that, the sine of omega 2 plus 5. So there.
But that was the one that.
But so at the maximum, that sine of blah, 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 to maximize it, we want that sine to equal 1.
Oh. So it's just one.
Exactly. Does that make sense?
Yeah.
That what you just realized is super important. Everybody got that? Yeah, shoot.
In any scenario where we're just trying to find at a certain point, how to go on 5.
So let me see. Let me keep moving through the problem, and if at some point you don't do that, remind me at the end and let's come back and do it, because it's a thing you should for sure know how to do. Clear? All right. Is everybody good with what we've done so far? Okay. So numbers that we might need again, let me highlight these just so they kind of stand out. So we need our mass, we need our x max, we need our period. This was our V max, so we might possibly need that. Oh, that didn't do what I hoped it would. We found our omega. All right, cool. Let's see, part B. What is the number of times per second that the maximum is reached? So, how do I want to say this? So in one period, or you got an idea, Patrick? Okay, what do you got?
The amount of times per period, well, the amount of times per period by the period, so maybe like a ratio of times per period of the x or the 1.
Okay, yeah, it basically boils down to dimensional analysis. So the question is this. In one period, how many times will the thing hit maximum velocity? Every time it goes through equilibrium point, right? So the period is the time it takes to go there and back. How many times does it go through the equilibrium point? Twice. Once here and once here, right? Follow? So, to do part B, we're going to say, all right, well, we have 2 maxes per period, right? Follow? Times 1 period is 0.04 seconds. So if I simplify that, I'm going to end up with maximums per second, right? Make sense or no?
Yeah.
All right, so that gives you 50. Cool? If it helps any, we looked at this. Remember when we made these kinetic energy graphs? Right? Remember we said that the kinetic energy kind of completes cycles with twice the frequency as this, right? Because of those squares. It squares out your negatives, right? Okay, so this shows us those two maxes in one period, right? Cool? All right. Chugging along. All right, let's see. So that was B. C, what's the spring constant? What am I really asking you for? K, right? And we decided that K was, what, m omega squared? So 0.02 kilograms times omega was 157 radians per second. Don't forget to square it. Yeah. And it gives you, hopefully, 494. Newtons per meter, somewhere in that neighborhood. I think the 157 is rounded, so if you got 493, that's why.
Yeah.
Cool? So do me a favor. We ought to be able to now, let's check what I had said before. Let's find our maximum EPE. What should it be? What should the maximum elastic potential energy be? 1.21, right? It should be the same as our maximum kinetic energy was, right? So check. EPE max equals 1/2. Our K is 494. Times our X max is what? 0.07 squared. Anybody have a calculator handy?
Yep. 1.2103.
1.21 joules. Hooray! Physics. Cool? Any questions? All right. D, what's the block's velocity when it's at a position of 4 centimeters? So position at 4 centimeters. So we're looking for the velocity here or here, right? So notice we're going to go to positive or negative, right? It's that position once on the way there and once on the way back. So thoughts about how to find that velocity? Sure, yeah, Patrick.
As the time position, plugging x versus b. Wait, no. Yeah, plugging x, and then
What do you mean when you say find the position? You're given the position. It's 4.
will be time and then.
Oh, position as a function of time?
Well, yeah, you're given the position that you like plug that in and find the time that it's at, and then use that time in the velocity equation.
Got it. Does that seem intuitive to you guys? Okay, so this is going to satisfy Adam's question before, all right? I will say that what we're about to do I don't think is the easiest way to solve this, all right? It works, but remember, question E says there are 2 ways to do part B. So this is one of the ways. I think the other way is easy. And let's do it just so that you kind of know what's going on. All right, so Patrick, what I'm hearing you say is you want to come up with this. So to do part D, you're saying, I want to come up with an expression for that, right? And solve for the time at which that occurs, right? And then plug that into the velocity equation. Okay, that makes sense to me. All right, so some of these numbers we already know. So position at time t is our x max is 0.07. Is it bad if we switch to centimeters? Is that going to mess people up? If I do centimeters and centimeters per second, or do you want to use meters? Just use meters? Okay. All right, cosine, let's see, our omega is 157 t plus 5. All right, so now we got to resolve Adam's question, which was how do you find phi or phi? So, thoughts? Say that again.
D gives you x with t, right? Since I'm in a position of 4 centimeters. So again, you plug in 0.04 equals.
Oh, I got you. Yeah. Oh, well, but we don't have the time at 4. How about you guys? What do you got? How can we find phi? Let's vote real quick. I'm sorry, this is distracting me every time I say it. Who likes phi?
He's actually the right way to say it.
There is no right or wrong? There's no right or wrong? 1, 2, 3, 4, 5, 6, 7, 8. Who likes 5? Oh, I think so. 1, 2, 3, 4, 5, 6. Can't have a tie. All right, give it to me. Here it comes.
So I went to preschool for years of my life, and you saved me.
Oh, really?
Yes.
All right, I like going to the Greeks instead of the Red. All right, get out of here. All right, here we go. Back to physics. All right, I'm sorry. All right, so we got to figure out how to find phi. So, yes.
So to find phi, what do you try to do?
What do you mean?
Like, the notes made it seem like you were trying to make it look like a sine curve instead of a cosine.
Oh, no. We want to leave it as a cosine curve. Phi is a number. I want to find out what that number is. That's it.
You find it using the graph.
Yes.
So what do you try?
All right, so look, you guys, here. Let's do something different for a minute. It's the exact same thing. Suppose I give you this line. And you know, I don't know, this point and this point, and you want the equation for the line. What's the first thing you do? You find the slope, right? And then you go, oh, cool, y equals slope, which here is very clearly 3/2, x plus b. And then what's your next step? Find b, right? How do you do it? You pick any random point, plug in x and y, and solve for b. This is the exact same thing. It's literally the exact same thing. We've got a graph for which we know all of these values of x and t, and we're trying to find phi. So pick any value on your graph, any point on your graph, plug them in and solve for phi. Does that make sense? So, what's a simple choice? Do t equals 0. I can clearly read the graph. At t equals 0, x is 0.07, right? So, 0.07 equals 0.07 cosine 157 times 0 plus phi. Right? Oh, these guys cancel. I got 1 equals the cosine of phi. Oh, phi must be 0. Oh, that makes me happy. Good? And I'll be honest with you, on the AP test, it probably will always be either 0 or maybe like pi over 2. It'll be something simple, you know. What's your name? Sarah.
Here's what I'm writing to.
Sorry?
0.07 on this x of t.
Uh-huh.
Is that just because it's 0.07, like the distance is 0.07?
Yeah, just by reading the graph. You look.
So
If
then
you look at t equals 0 and follow the graph up, you're at 0.07.
the x of t is the same thing as xx.
So at times 0, you happen to be at the max.
Okay.
Follow? Like, if that doesn't make sense, I mean, you could have,
I got it.
we could have picked this time, 0.01 seconds, and made x of t 0. Good?
Yep.
All right, is everybody good? All right. So now, yeah. Yes, you could have, yeah, totally. Yeah. Did you just miss it, Josh? You just said you could also, if you know what the graph cosine looks like, you could have just known, well, cosine of theta starts at a max, so your phi had to have been 0. It's not shifted. The cosine graph isn't shifted at all.
It's
All right. somewhere I have a marker. I don't know where it is. I'm going to use this one. Here we go. All right. So, so now I've got my equation for position at time t. So Patrick, I'm picking on you again. So what was your idea now? What was our original question that we were trying to solve half an hour ago?
T. Wait, no.
Four.
Like C?
What is the question asked? Question?
Plus velocity when the position of 4.
Yeah, what's the velocity when the position is 4? So what should I do? Put in 4 for my position and solve for t. Right? And solve. And if you do that, I'm going to skip the algebra because I believe that you guys are all capable. The t turns out to be 0.006 seconds, I think. Is that what my scribbles here mean?
Yes.
Hey, guys.
That was my phone.
That's what I was. That's what I was asking about earlier. If you could just plug it in for it, but we didn't have the phase activity.
Right, exactly. Understand?
Yeah.
All right, so is everybody good? All right, so am I done? No, what do I need to do now? Find the velocity at that time. So what's my equation for the velocity at that time? So remember, it's just the derivative of this. So I'll be honest, you guys, this is the only equation in this chapter that I memorize. Everything else, if I need it, I derive it. Okay? So the velocity, I'm going to take the derivative. So derivative of cosine is negative sine. Chain rule, you're going to bring an omega out. So you end up getting negative omega xm sine of omega t. And we know our phi is 0, so I'm going to not worry about the phi. Phi, sorry. All right? So what I'm looking for is the velocity at 0.006 seconds. So that's negative 157 times our x max, which is 0.07, times the sine of omega, which is 157, times our t, which is 0.006, and solve that. Good? What's wrong? Okay. So when you solve it, the velocity ends up giving you somewhere I have it.
It says 9 on the paper.
Oh, 9.
Negative 9.01.
So it's negative 8.9 or whatever, 9 meters a second. Do I need to worry about the positive or negative in this problem? I'm looking for the velocity when the position is 4 centimeters. Sometimes it's positive, sometimes it's negative. So technically it could be either, right? Follow? All right, any questions on that? All right, so that worked. Any problems with it? That was part D, right? All right, so E wants us to go back and do that again a different way. So that works. There's an easier way. And I like this way because I think it helps you kind of understand the connection between the different graphs and position at time t and velocity at time t. Cool? All right, so anybody see the other way to do it? Conservation of energy. So check it out. We know that our EPE max is equal to our KE max, which is 1.2 joules. Isn't that our total energy? Cool? So, when x equals 0.04 meters, we have EPE plus KE equals the total energy, right? 1.2 joules. So I'm looking at 1/2. We already found K, it was 494, times X, which is 0.04. Don't forget to square it. So that's the EPE. Plus the KE is 1/2 the mass times V squared equals 1.2 joules. And solve it. Holy cow, that's way easier. Follow? All right. So these conservation of energy is a real efficient way of finding the velocity at a point or the displacement when the velocity is something. All right. Questions, you guys? I think I'm done with you unless you guys have questions for me.
Hey.
All right, so why don't we do this? So you got, I know it's not a ton of time, but you got 15 minutes. So if you didn't notice, the schedule for next week is on the board over there. So worksheet 15.1 is due Monday. Tuesday, I thought we'd make a work day, unless you guys have more questions you want to go over. We'll make 15.2 due on Wednesday. Thursday, we've got a half day, so we'll be last today. We'll do test Friday.
Sorry.
That gives us 2 full weeks to practice AP stuff. Cool? All right, now, tomorrow you guys will be doing the lecture for 15.2. I've said this before, and you guys often don't follow my advice. So if you leave all of 15.2 for Tuesday, you're not going to finish it. All right? You've got the weekend. So try to get started on the 15.2 stuff over the weekend. All right?
Mr. Record nervously laughs.
I think 15.2 is shorter than 15.1.
Oh no, there's probably.
All right. And actually, now that I look, 15.2 is shorter. So that's
15.1. Nice.
Thanks, Sebastian. I appreciate it. Why do you say that?
I don't have what?
That's what I thought you were just saying.
No, I said we don't have
But I
Yes, you do.
which day you would be last time? Were you folded?
But doing you get to put that on the
It's either or
because at all of the like not for but like all the things that we went through, like yeah, that's like you guys. Probably, but I wish I knew what classes I was taking.
Yeah.
almost all of them.
I got nothing wrong. Sorry.
Yeah, but
I don't think there's a set policy on it.
Yeah, we're gonna have to get.
oh yeah. They say that physics and like English stuff.
One of my buddies
Yes, makes sense. I've been like talking to him every day about this stuff.
Make it
Said take did you talk to you about that?
I have.
So you can do 2 ways in second semester.
Sorry for your loss.
It might be
All right, hey guys, real quick about to your point. Here's the deal. So the first year students have until May, I think it's 4th, May 4th to turn in their slips. And at that point, whatever spaces are open, I can offer up to you guys. But they get dibs because they have an actual assignment. That's the first year point. All right, I think there will be space for you guys, but I cannot promise. It depends on what happens with Mr. McGuire. So I will let you know as soon as I can.
What if we drive out?
Then you need to be excused and
Like,
if you are excused, you know what I mean? Like, I think if you go not with us, then you go not with us. That's makes sense.
Isn't that stressful? I can't imagine.